Unfortunately, I will do the presentation in English because I don't speak French. So what I will talk about is the ACEGES project. So the ACEGES stands for Agent-Based Computational Economics of the Global Energy System. So the idea we had was to develop a computational laboratory that will enable policymakers and chief executives in the area of energy to make long-term investment decisions. But our aim was not only to develop the ACEGES project for policymakers and business executives, but also to integrate that idea into our educational program. So we have introduced ACEGES in the undergraduate and postgraduate programs, and a number of PhD students are also working in this area. So why we have done the ACEGES project is because we have understand that businesses need to start thinking more sustainably. They need to move away from the idea of maximizing the shareholders' value in the short term and start looking about the overall profile, sustainable profile of the businesses in the long run. And by long run, I mean the next 40 to 50 years, not the next 2 to 3 years. We also understand in the business school that we need to develop robust long-term strategies, strategies that secure the survival of the businesses no matter what's going to happen into the future. So how we're going to do that? We're going to do that by developing a computational laboratory that builds an artificial society inside a computer. And using this artificial society, we try to explore possible futures. And we call these possible futures scenarios. So using the ACEGES software, we develop various scenarios about the future. And the scenario developers must use this computational tool because it enables them to capture better the uncertainty. So although scenarios is not a mechanistic process, it's a mental process, we think that with the use of computers, an artificial society, people can better explore the uncertainties of the future. Policymakers really should use scenarios in order to design policies that maximize welfare value. But also business strategies should use scenarios in order to test the resilience of their strategies. And our students are introduced to the idea of the assets-based scenarios as a way of developing sustainable strategies and thinking about new business models. And I think because of what's happening in the 2008, students need to start thinking about new ways of doing business. So how we do that? How exactly have we integrated the ACEGES into the curriculum? The first approach we did was to do project-based approaches using real-world data set. So this is not an artificial data set just for the students to experiment on a case study, but we try to address a real-world problem using real-world data sets. Then we give to the students a single question. Every scenario needs to address only one question. And that's an example of that is what is the global production outlook of oil until 2050. So we give them a real data set, the data set that we have collected from our own research, and we also give them a single question. So their problem is now to try to understand what might happen with the global production of oil. The same thing can happen with gas, the same thing can happen with renewable energy and other forms of energy. Now, then the students form what we call the scenario teams, and this is made up of no more than 6 people. So using the scenario team, they try to address that simple question. Once the scenarios teams are formed, the students start doing a historical research. It is very important for them to understand the history and the present before they start looking into the future. So how they do that? They go and they investigate 218 countries. Our model describes the production of energy for 218 countries. So they look into population dynamics. They look into the economic dynamics of the countries. They also look into technological innovation. They look into the different energy sources because different countries, they have different energy potentials. And they also look into the land use. And then based on economic and environmental trends, but also looking into global trends and regional trends, they come up with a set of scenarios. What you see there in the screen is basically two sets of scenarios, the A and the Bs. And the A scenario is made up of two sub-scenarios, A1 and A2, and the B is made up of B1 and B2. So every single thing you see there, this one is one scenario, second, third, and fourth. We usually say that the maximum scenarios should be 4, and the ideal scenarios are 3. As long as we develop more than that, it is very difficult to understand how we can use the scenarios in order to test a strategy or to develop a policy that is going to secure the survival of the people within the remit of the policymaker. So what really they do then is, once they do the research about the historical perspectives, then they try to understand the risks. The scenarios really are developed about key uncertainties. Understanding the past is very important, but the key thing in every scenario development process about the future is the risk. And this is where they struggle most of the time. They try to think, what are the things that will happen in the future that will generate these different possible futures? And that risk is mainly about forces in the pipeline. In other words, are things that are about to happen, they haven't happened yet, therefore we don't know their effects. An example of that is the tight oil. We don't really know how quickly can we extract that, and we don't really know what is the impact on the environment. Is it a good strategy or not? So that's the kind of decisions the students they have to take. And then they use the ACEGES, and in order to come up with some decision scenarios. What is very important while they use the ACEGES is that to describe some stories about the future, but these stories need to be plausible stories. They are not science fiction. So there is always a distinction between describing something that might happen and describing a science fiction. So we try using the tool to teach them how really to describe possible stories, but not science fiction. So how they do that is effectively they have identified a number of uncertainties, as you can see there. These key uncertainties can be how much oil is on the ground, how quickly can we extract the oil, what is the demand for oil the next 40 years, and when it's going to happen roughly the peak point. And then using the scenario generator tool, which is the ACEGES, they come up with what might happen into the future. And then they have to understand what that means for a policymaker or what that means for a decision maker. If we use it as an example, what they're looking into the 20 most advanced countries in terms of the economic growth, they look into what was the performance of the country in 2009, and then they try to guess what might happen in 2050. And this might imply a lot of changes. So you see, for example, the United Kingdom from number 7 is likely to drop to number 10. However, we see China from number 2 is likely to become number 1, and number 2 is going to be India, and the US now is going to be number 3. But the interesting thing is also happening from Southeast Asia, where suddenly you see Vietnam that's coming out. Vietnam is not in the first 20 countries, but by 2050 is expected to be in the top 14 countries in the world in terms of the GDP. We also see Nigeria, we also see France, and obviously we see Germany number 9, Indonesia number 8. A key thing for them is to understand the economic growth, because economic growth is likely to impact on the demand for energy, and that's going to put a lot of pressure on the environment. We expect Vietnam will increase by about 8.8% per year the next 40 years. The next country is India with 8.1%, and next is Nigeria. We see, however, Canada is expected to increase by 2.2% per year, and United Kingdom 2.3% per year. This is very important because various countries, they have different elasticities of income of oil demand. And for most of the countries in Southeast Asia, economic growth is affected by energy consumption. In fact, the energy consumption grows faster than the economic growth. So that's not obviously the case with the OECD countries, but that's what's happening in some countries in Southeast Asia. And then they try, obviously, to relate, so what? The problem is that when we try to understand the evolution of the energy system and their effects on the environment and what it means for sustainable development, both for a country but also for a business, we need to think about electricity. How are we going to provide electricity around the world? They also need to think about transportation. The map you see down here is basically the track of a number of taxis in London. So you see the density of the taxis at night. And the other map is the airplanes. So when we move people and goods in and out of the United Kingdom. And obviously the map at the top is how the world looks like at night. So we have to provide electricity services and we have to provide transport fuels. And that is a key challenge they try to address. So they do that using the ACEGES model. So every dot you see there in the ACEGES model is called an agent. For this particular exercise, an agent is a country. And as I said before, we modeled 218 countries. However, various countries can belong to different organizations. An example is OPEC. So different countries, they collaborate in order to make a decision about the production of oil. But we also have the big energy consuming countries, the OECD countries. So we have the agents, but we also impose on these agents various organizational structures. And then we look into the different layers that affect the decisions of the agents. We look into the physical layer, how much oil is on the ground. We look into the business layer, what is the restrictions in terms of the investment plans. We look also at the socioeconomic layer that affects the energy demand for transport and electricity. And obviously, we look at the regulatory framework. How likely is to get electricity from coal, how likely is to get electricity from nuclear power, and how likely is to get electricity from renewable energies. All of these decisions will impact the scenarios, which is the one at the top figure here. So they have to think about all of these things in order to come up with a production profile for oil, for that particular scenario. So the ACEGES is based on a framework called agent-based modeling. It uses some statistical models. This is the R statistical package, which is available for free. We also use a framework called the generalized additive models for location, scale, and shape. This is in order for them to identify the uncertainties based upon historical data sets. But we also have events in the pipeline, things that cannot be analyzed with statistical models because we do not have the data yet. An example like that is the current unrest in MENA, Middle East and North Africa. What does it mean? It might be the Berlin Wall of MENA. So you might see substantial change of what's happening in MENA. And then they have to read more widely about what's happening right now with newspapers, and they try to understand the wider implications. We are aware about the unrest in MENA, but what if we need to look north and east of MENA, the former Soviet Union? What will it mean in terms of the production and supply of energy if there is an unrest in the former Soviet Union? What will mean the relationships between Turkey or Pakistan? How this might affect the transportation of oil and gas in the region? And that's all of these things, they have to put it into the scenario design in order to explain what's going to happen in the next 40 years. Then they go into more details. This is a key uncertainties in terms of oil. So I'm going to go a bit more specific, so the way they try to think about that. This is real data set. It's from particular fields in countries. So you see a particular field called Somoltar in Russia. You see also what's happening in Alaska, in Norway, and the United Kingdom. So the uncertainty you see there is how quickly can we get from the discovery of an energy resource into the maximum production. And one of the things we observe is that in Alaska, for example, that has been a very rapid increase. But in Norway, the increase goes smoother. That's the first key uncertainty. How quickly can we extract a resource once it has been discovered? The next key uncertainty is when it will peak. In Russia, the peak happens when 42% of the whole oil mountain was consumed. So when the cumulative production from the 1970s to the 1980s amounted to 42% of the overall oil mountain, we experienced the peak. Obviously, we experienced something different in Norway and substantially different in the United Kingdom, when it happens at 30%. So the key uncertainty is when we move away from economics and technology into physics. Because there is a stage where the more oil you extract, the pressure drops, therefore the physics dominates. And we see that different fields experience different behaviors. And once the peak happens, the third uncertainty is how quickly it drops. We see in Russia it's very different, the drop, compared to Alaska, which is much smoother. And that has to do with the management of the energy resources, but also has to do with the technology that's used by the different countries. And all of these things, they have to analyze it for 218 countries. And obviously the biggest uncertainty, how much is on the ground? This is two different estimates. One is from the Geological Survey, which they estimate about 2 trillion barrels, but we hear from Campbell where the estimate is effectively less than 2 trillion. So in fact, we have rough ideas about how much oil is on the ground. So the conventional approach, in order to encapsulate all of these things, is to assume a particular production curve. This is a Gaussian distribution, this is a linear, and this is an exponential. And using this assumption, based upon historical experience, we try to see what's going to happen into the future. And in most cases, it works well. For example, we see that for Alabama, the normal distribution seems reasonably well. We see also the exponential one looks okay for Albania. The problem is there are cases where it doesn't work well. So what they do is, understanding the different uncertainties, they try to come up with ideas when the peak is going to happen. 2026, 2037, 2047, by fixing the economic growth on 2% for all of the countries, and by assuming a particular reserve-to-production ratio. So in other words, the classical approach is to use specific points about the uncertainties, you plug to the model, and you come up with a number of scenarios. Our approach is different. Our approach is there is an uncertainty about the different peaks. Therefore, we try to predict that uncertainty. That's very important for risk investment decisions. So the darker the color, the most likely the outcome. The lighter the color, the less likely the outcome. And the way we do that is by running a lot of simulations. Here you see one particular simulation. Every color represents a country. And for every simulation, we have one data point. We run that 100,000 times, and we come up with a distribution for a particular year. And we do that for all of the years, so for the next 40 years. And that comes up with that figure that shows the distribution and the risk for every single year for the next 40 years. So the way we do that is by replacing the points with distributions. Here is the different distributions that we assume based upon historical experience. We plug into the model and we come up with what we call continuous scenarios that will quantify the balance of risk between the different possible outcomes of the future. We do exactly the same thing, not only obviously for production, but also for crude oil prices. And we try for every particular point in time to quantify the risk. So this particular risk has a very different behavior than this particular risk up here. So here, basically, the chances of having a massive increase in the oil prices is much higher compared to what's happening in the case when we are at the lower side. We do exactly the same thing for the oil cost curves. In other words, we might have oil on the ground. There is enough oil on the ground in Canada, but how much will it cost us to extract that? So we make different assumptions of how much oil is on the ground, and some assumptions about the cost of extracting the oil. And what we observe is that although we might have even 4 trillion barrels, the cost of extracting increases dramatically, but what also increases is the variability. And that's the worst case scenario for a policymaker and for an executive in a big oil-consuming company. Because not only the cost goes up, but also the variability goes up. And effectively, then what we say to them is think about unrest. Think about what might happen not only in Libya, but also what might happen in Saudi Arabia, what might happen in Qatar. So what the students are doing simulation of different unrest. And that was a stage where I was supposed to show you a demo because I have the software with me, but I couldn't plug it because we have to have access to the TV. But if someone is interested to see how we do that, I'm happy to demonstrate you the software afterwards. And that's the end of my presentation.